Hello, we are a group from the fall 2022 electrical engineering sophomore design classes. Our project was designing and building a wind sensor unit for a weather station. I am Austin Davis.
I am Joshua Long.
I am Derek Munoz.
I am Jaihan Chailawan.
Our wind unit measures three characteristics of the wind speed, the wind direction, and the wind chill. These are measured using three sensors: an anemometer, a wind vane, and a compass.
We choose to use a 3-cup anemometer because it, at a single output signal, is resistant to changes in unrelated weather conditions and is relatively inexpensive. We chose the Adafruit 1733 for its relatively low operating voltage of 7 to 24 volts DC and its analog output of 0.4 to 2 volts, which is ratiometric to the wind speed.
The wind vane was constructed out of 3D printed ABS parts and a magnetic encoder, which detects the absolute orientation of the wind vane using a magnet that is attached to the rotating axis. We chose the AS5600 for its relatively low operating power of 50 milliwatts and its 5 volts analog output that is ratiometric to the angular position of the magnetic field from the attached magnet. Because the weather station uses a TIVA-C microcontroller, which operates with a maximum of 3 volts, the output signal from the encoder was attenuated using a voltage divider.
The compass was created using a magnetometer to detect the Earth's ambient magnetic field. We chose the LIS-3MDL for its high sensitivity and precise detection range. The LIS-3MDL communicates using the I2C protocol. We tested the Adafruit anemometer and the magnetic encoder using an oscilloscope for their ratiometric voltage output. Both sensors were integrated with the weather station without calibration. Initial readings of the magnetometer revealed that it needs to be calibrated to correctly determine the compass direction. The calibration process is performed using MotionCal, which calculates the offset of the raw magnetic field readings to produce the correct measurements. The calibrated magnetometer was compared to a phone compass to confirm accuracy, which was found to be plus or minus 20 degrees.
Further testing of the Adafruit anemometer for precise calibration was not possible due to the lack of available wind tunnels. The wind direction relative to the cardinal direction is calculated using the angular measurement of the wind vane and the weather station. The calculation is a subtraction of the compass reading of the magnetometer phi from the wind vane angular position theta measured by the magnetic encoder.
Wind chill is calculated using the equation shown here, where T is the ambient temperature in degrees Fahrenheit and V is the wind speed in miles per hour. All the sensors are wired in a single PCB that interfaces with the main microprocessor hub of the weather station. And they are all integrated into a single enclosure made using 3D printed ABS. The enclosure is mounted onto the top of the weather station's tripod via a metal frame. To ensure that the wind vane's magnet doesn't interfere with the compass function of the magnetometer, the two sensors are positioned approximately 1 foot apart.
After integration with the weather station, all sensors function properly, and the weather station microcontroller can read and send out the correct measurements of the wind condition in real time. Calibration of the sensors was not ideal, but they are accurate enough for the project scope.
The largest flaw in the final wind unit, as seen here, is the enclosure. Due to the unexpected magnetic interference of the wind vane's magnet on the magnetometer, a single enclosure could not be used, and a separate enclosure had to be attached to separate the two sensors. The two enclosures drastically compromised the unit's aesthetics and weatherproofing.
If a different position sensing technology is used for the wind vane, or if the magnetometer is shielded from the magnetic field of the wind vane's magnet, then the two sensors can be housed next to each other with no interference. This concludes the presentation of our sophomore design project. Thank you.